In this lesson, we are going to talk about geometric sequences, how they are different from arithmetic ones, two real-life examples to put it into perspective. Then we're going to talk about geometric series, also known as sum of geometric sequence. Then we're going to briefly cover sum of an infinite geometric sequence, and then to top it all off, we have an excellent question to make sure you understand the topic. So, geometric sequence itself is quite similar to the arithmetic one. Its formula is the following: un equals u1 times r times n minus 1. And here the r means the common difference. And the main difference between the arithmetic sequence and geometric sequence that you really have to understand is that n is multiplied with d. And comparing these two, d and r are the same. However, in arithmetic sequence, the n is multiplied with d. And in geometric sequence, r is in the power of n. Therefore, you can understand that d is always constant. And r isn't constant, because as n grows higher, n becomes even bigger. So this might seem very confusing at first, so let's look at two real-life examples to understand this as well. So the first one is a beautiful car, and we understand that the price of the car in the first year is 100,000. And we want to find how much the car is worth in the year 15. Then we use the formula u15, because we're searching for the 15th term, equals u1, and u1, as learned from the previous lesson, is always the starting point. We can write that down even just to make sure. So it's $100,000 times r, and in this case, if we see that the value goes down by 15% every year, we have to understand that the value remaining is 0.85. And then, because n, we also, just to make sure from the previous lesson that you remember, n is the number of the term, and it's usually a time period. And in this case, as we're searching for the 15th year, then we put it to the power of 15 minus 1, because that's the formula. And we get the answer from using our calculator: 100,000 times 0.85 to the power of 15 minus 1. And we get the value to be 10,076. And therefore, it's actually very understandable how the geometric series works, geometric sequence works, because the value of the car depreciates over time, and it can be modeled like this. And another example of this, we can take a TikTok post. We can understand that, let's say it doubles every minute. The likes double every minute that it's out. So in the first minute, minute 0, it has 5 likes, let's say. And we want to know how many likes are in minute 10. So let's go over. u1 is obviously 5, because it's the starting point of the geometric sequence. And we know that n is 10, because we're searching for the 10th minute. And in this case, r is 2, because r is something that we look when it's doubling or decaying, growing or decaying, I'm sorry. And so we use the same formula. u10 equals 5 times 2 to the power of 10 minus 1. Then we plug it in. And we get that in the 10th minute, it has a total of 2,056 likes. We can draw that here. And you can also draw this and understand this from a graph, that because it's modeled as geometric sequence is modeled as an exponential graph, the likes or the amount of growth is also exponential, meaning that the growth can be modeled in a way that it goes up in a time of period faster than the time. So we can conclude from this that if r is bigger than 1, then it obviously symbolizes growth. However, if we look at here, if r is smaller than 1, for example 0.85, then r is decay. So geometric series and the sum of sequence as well is something that we also learned in the previous one. However, it's a bit catchy in this one, so it has to be went over as well. So the formula is completely different. The formula is Sn u1 n minus 1 and r minus n. So this is actually the formula. However, there's a catch to this. If the r is if the absolute value of r is smaller than 1, then we cannot use this, because this part would go into negative. Therefore, if your r is between 0 and 1, that's very important, then you have to flip the formula and you get the different formula, which is Sn u1 1 minus r to the power of n and 1 minus r. And this you use if your r is between 0 and 1, and this you use if your common ratio, also known as r, is bigger than 1. So let's briefly also cover sum of an infinite geometric sequence as well. If you start to think about it, let's go, for example, the likes that we had before. You will start to see a pattern that if I draw a geometric model, over time you see that it will not go as much forward. And at one point it will stop going horizontally and only go vertically. So therefore, if you have an infinite geometric sequence, if you have a geometric sequence, then at some point it will end. And this will be also given by a function that S infinite is equal to u1 1 minus r. However, this you can always flip if your r is between 0 and 1. And this is actually a very common question in the paper 1 and paper 2. So this is a formula that you have to remember, but no worries, it's always in the formula booklet. So to top it all off, let's conclude this with an excellent question. So on the 1st of January 2025, the Faber car company will release a new car to global markets. The company expects to sell 40 cars in January 2025. The number of cars sold each month can be modeled by a geometric sequence where r equals 1.1. So let's start with A. Use this model to find the number of cars that will be sold in December 2025. So obviously the 1st of January is u1, and you will understand from the text that in January they sold 40 cars. So you can really write everything down and put that u1 equals to 40. And our r is also given, and our r, or the common ratio, is 1.1. So the question states that we have to find how many cars will be sold on December 2025. So we can just clearly understand that it asks for the last month. And I think it's quite obvious that we all know that December is the 12th month. So n equals to 12. And then we can construct our formula. u12 equals to 40 times 1.1 to the power of 12 minus 1, straighted from the formula. Then we can use our calculator. 40 times the common ratio to the power of 12 minus 1. And you get the answer of 114, which you have to round to 3 significant figures, is equal to 114 cars in December of 2025. And B is definitely way more harder. It asks to use this model to find the number of cars that will be sold in the year 2025. So the first part asks us to find the number of cars sold in 2025. And we all know that there are 12 cars, 12 months in that year, so we can really already write it down as S12. The n is obviously 12, and r is still 1.1, And also the starting point U1 stays the same, which is 40. So we can always look at our formula booklet and look at the formula given. So we can just go 40 then we put 1.1 to the power of 12 minus 1 divided by 1.1 divided by 1.1 minus 1. Then we can use our calculator to get 40 1.1 to the power of 12 minus 1. And then to the bottom we put 1.1 minus 1. There's some reason no need for duties. And you get the answer of 855. And as you have to round to 3 significant figures, you can say that in 2025 they sold 855 cars. So the next part is more tricky. There are several ways to answer this question. However, I think the most obvious one that I will definitely use is to just search for S24. As we're searching for 2 years, then we can just find the amount of 2 years and then subtract the first year to get our answer. So let's start by finding S24. So we will use all the same data of N24, common ratio being 1.1, and the starting point being at 40. And I can do this. So it's 40, 1.1 to the power of 24 minus 1, and to the bottom we just put 1.1 minus 1. Then we can see that they've sold within the 2 years about 3,039 cars. And because this is not the final answer, we have to also add in the decimal places. And then we can simply take the answer from here. And since S24 is 2 years, and we only have to find 2026, then we will just subtract the first year from the 2 years, and then we will get 3,039.89, etc. And we have to subtract it from our first year. We subtract this from our first year, which was 855. And when you're doing calculations, please don't round anything. And our total answer will be 3,039. And we will get that in the second year they will have sold 2,684 cars, and because this has to be rounded to 3 significant figures, they will have sold approximately 2,680 cars.